The example we'll look at here comes from 10.2.1, but I'm only using the data right now for that hypothesis test. Here we have a random sample of 11 statistics students, where X is a third exam score out of a total of 80, and Y is the final exam score out of 200. And the question is, can you predict the final exam score of a random student if you know the third exam score? We're going to talk about the predictions after we talk about the regression equation, which will be in the next section. So right now, let's just focus on testing if there's a linear correlation. Our preliminary step is to check requirements. First requirement, we have a simple random sample. We know it's a simple random sample because they tell us it is. We need to do a scatter plot, and we need to look for outliers. So let's pull up Excel, and I already have my data inputted. Let's create a scatter plot. Select our data, insert scatter plots. It gives us a title, only because I selected the X and Y labels. But I'm going to change this. So we have a scatter plot. We're going to add our axis titles. It seems like all of the data is contained pretty closely together. The determination of an outlier can be a tricky one. Most outliers will be very obvious, the ones that we need to throw out. So we're going to keep all of these in. And I'm going to grab this, put it down here for us. We've got our scatter plot. It looks like there could be a relationship. And then we go to the next step. State the hypotheses. State our hypotheses and identify the claim. The null hypothesis is always rho equals 0. The alternative hypothesis is always rho does not equal to 0. Since it looks like there could be a linear relationship, I'm going to make the alternative my claim. Generally speaking, we'll make our alternative hypothesis the claim. And again, remember, the null hypothesis means there's no linear relationship, but the alternative means there is a linear relationship. Next step, find the critical value. And our critical value comes from T inverse 1 minus alpha over 2. Well, we don't have an alpha in this problem, so we get to choose alpha. It's a good choice to make alpha 0.05 if we are not given the significance level. And this is 11 students, so we have 11 pairs of data. Our degrees of freedom will be n minus 2, 11 minus 2. So let's calculate that. So t.inv, the probability 1 minus 0.05, divide by 2. Make sure you get that 0.05 in there. And then our degrees of freedom, 11 minus 2, which would be 9. You can either type 9 or 11 minus 2 and make Excel calculate it. And if we hit enter, we get a critical value of 2.262. But since this is a two-tailed test, our critical values are plus minus 2.262. Then for step 3, we can compute the test value or the p-value. We're going to do the traditional method here. And so first up, we need our correlation coefficient. So let's go into Excel and we'll calculate R. So R equals correl. And we'll come up here and grab the first column. And then we'll grab the second column. And our R is 0.663. And that might be significant or it might not. 0.663 is close to 1, but how close to 1? That's the point of the hypothesis test. The hypothesis test gives us tools so that we are not just guessing. So once we have our correlation coefficient, then we can put it into the test value calculation. T equals R times square root n minus 2 over 1 minus r squared. So that's our formula for our test statistic, our test value. And when I'm in Excel, I can type it out. So r times square root and minus 2 on top. Notice my use of parentheses, they're really important here. 1 minus r squared. Or if we're doing it by hand using our calculator, we can plug in the numbers and use our calculators for that. Since I have Excel here and I already have my r calculated, I'm just going to do my calculation in Excel. So r times square root n minus 2 divided by 1 minus r squared. And we hit enter and we get 2.657. 2.66. Double check that number. 2.65. Could do 2.658. Going to 3 decimal places. And there's our test statistic. Now we need to make a decision. So step 4, make a decision based on the hypothesis test and the test statistic. So let's draw our t distribution. We have our critical values 2.262 and negative 2.262. We have rejection regions in the tails. Then we need to place our test statistic on this graph. So 2.658, 2.262, 2.658 will be to the right. It's in the rejection region, which means we reject the null hypothesis. And our last step, we need to summarize our results. We can say there is enough evidence to support the claim that there is a linear correlation between the third exam score and the final exam score. In the next section, we'll look at what that linear equation might be, and we will use that linear equation to make predictions. We found there is a linear correlation, so we are able to use that linear correlation to make some predictions within reason.